structural failure that happens many, many times, that we are over enthusiastically hopping into the proof of concepts, not being honest about the costs that we expect before we can move stuff into production. And just take this rule of thumb. It's a factor of 5 to 10, compared to the proof of concept costs.
The new oil is attention, especially for engineers. So how can we teach engineers to use AI tools more intelligently? What's your take on this?
The 95% of proof of concepts failing or not being continued and deployed is an interesting number and a shocking number.
All right. Thank you, Boris, for joining my podcast today. Pleasure.
Thanks for having me, Josef. I'm excited.
Yeah, likewise. I think we've been knowing each other for quite some time. I actually forgot to count, but probably 5 to 6 years minimum, I guess.
Yes, I think so. We met in the context of one of our first Siemens AI with Purpose summits that had been the conference around AI in industry that we organized for quite a while, right? So we started with that conference in 2022 to really provide a discussion forum of industry experts around, is AI industrial grade? What does it still take to make it industrial grade? Quality attributes of AI, quality management of AI, scaling AI in industry. And I think even if, 5, 6 years passed, those are still the topics that we are challenged with today, right? If you look into agentic AI, for example, there are many, many unsolved quality management challenges. And still everyone is excited about its power.
Yeah, absolutely. We have a couple of things to talk about. One of the things I really like is the title of your book, Industrial AI from Pilot to Profit. Why do I like the title so much? Because, we can talk about platforms like LinkedIn all day long. And I feel there is a lot of hype around systems that are not production ready yet. So the title I like so much because you're actually talking about the real practical applications, especially around engineering. Let's get started with the book itself. Like, why the title? Why is it so relevant nowadays?
Because we have those challenges specifically in industry to make AI industrial grade, and the pains of moving from an idea to a proof of concept, and then even the bigger pain to move from a proof of concept into a scaling production. These pains are so huge that I wanted to provide, to write this book basically for 2 reasons. One key motivation is that we need to reset expectations where AI in industry is and how AI in industry scales. And why do we need to reset expectations? Because many of us, particularly also our top managers in a company, they have touch points with AI in their daily life. They are using ChatGPT by themselves. Their kids are using ChatGPT to do their homework, right? So every one of us, independent from the industry in which you work in, every one of us is influenced by what is possible on the business to consumer side. Every one of us is amazed and has some touch points to what's possible with AI on social media. And of course, this sets expectations, and this sets very high expectations. But then social media and internet search and YouTube videos and ad placements, all of that is a pure digital business. So the scaling of AI, of intelligent algorithms across a user base, across a certain use case, is so much easier than in the physical world of industry with, its shop floor components, its complexity and the product design and so on and so forth. So I wanted to write a book that helps top managers, including, for example, venture capitalists, right, to understand why we have to ground the expectations for the use of AI in industry a bit. And then on the more positive side, I'd like to inspire people with what is actually possible. And I have many, many examples of how AI already makes huge differences to companies today in terms of their competitiveness, even helping to develop strategic differentiators on one hand. And then on the other side, half of the book is really about crawling through each and every function of an enterprise, of an industrial enterprise, and providing examples of how AI can support that function. And I'm
Yeah.
really talking about accounting and finance. I'm talking about HR and recruiting. I'm talking about providing services. I'm talking about procurement, intralogistic, production, you name it, right? So an industrial enterprise is much more than just production. It's product design, but it's also accounting. And I'm crawling through all of these functions, and then with the examples, I provide solution briefs, and the solution brief is actually a provider of a commercial AI solution that helps to improve that particular function. And this inspires people. So if you are running an AI initiative in your company, you can almost use this as a library, as a book to look up what's possible, and even have a first touch point to an interesting startup that helps in a certain area, or a couple of other larger players that are offering solutions, including, for example, Siemens, right, for product design and simulation and so on and so forth.
Absolutely. You concretely, like we talked about the title, you name it from pilot to profit, but obviously there's a gap in the middle. Like, how do you take something from a pilot to actually being profitable for the organization? So the question becomes, what lies in between? How do you make a pilot successful? And maybe before that, how do you even pick a pilot? It's a more interesting question.
So I see two key motivations to pick in projects within an initiative. One key motive, and it's a good one, by the way, can be to say, I'd like my employee base to have a learning curve, right?
Mhm.
And what is my expectation? In that very moment, my expectation is not that my company will be in a better competitive situation on the market in the morning of the next day. However, I'd like to allow my employee base to learn and to experiment and to find out about the new technology. And this is why if you are supporting this way of experimentation, you cannot apply a very hard return on investment calculation as the base for every attempt and every trial and so on, right? So people, for example, working with large language models to support the marketing function or to support the generation of job profiles in HR, right? These are commodity use cases, and we should foster them and we should allow them, because we also want the HR department to get familiarized with AI and what AI can do and so on and so forth. But this is a training exercise. And what you can expect is marginal productivity increases by these use cases. But if you really say, no, wait a minute, I need to prioritize and only take those use cases who change my competitive position in the market, you probably will filter out most of them. And the second pillar that you should be looking for is, what are strategic, respectively differentiating use cases. And I use both terms for the following reasons. If we say we are in a B2B environment and the products we are selling are complex products, right? And they are configurable and you need to be aware of the complexity of those products. Then in the end of the day, we need to train our sales force to be able to explain those products. And AI can be an instrumental tool to help the salespeople understanding the portfolio better and the configuration rules better and so on and so forth. So it's a strategic imperative to enable your sales to sell better. Does it change your competitive position on the market? I don't know. Strategically important, but not differentiating. And then you have differentiating use cases, and I know you have a very strong CFD background, and you know what design space exploration is. We have a couple of examples where AI really supports design space exploration to develop, with the use of simulation, with the use of generative design, products that from a performance level are really on a new level, are outbeating the competition. And these are the important use cases that are differentiating use cases, strategic use cases that the company should truly invest and prioritize. And now, having said that, you can even say the way how I look at AI initiatives from an accounting perspective, I do this differentiation, right? I have one cost center that covers the learning curve and the commodity use cases and the experimentation everywhere that I would like to allow. And I'm not super exact on return on investment calculations because I know this is training. This is workforce enablement. And then for the big ones, also from an investment perspective, the big and focus ones, I really need to make sure that I get a solid understanding what my return on invest will be for those use cases.
Yeah, there's an MIT study, Boris, which says that 95% of organizations get no return on their Gen AI, like specifically there was a study made on Gen AI investments. Do you know about any numbers in the engineering space? And also, why do you think these use cases fail? Is it like a not meticulous filtering process? Is it also that the idea itself is already being logically flawed since the beginning? Or do people have overinflated expectations about what AI is capable of? What do you think is the phenomenon? And I think what you talked about, Boris, maybe before you answered the question earlier, is very important. I think especially in engineering, especially the management positions, I think they have no sensitivity about what is possible with AI and what's not possible, because I think everybody has the perception of AI is AGI. Therefore, it can do everything for me. Therefore, I have a return on invest. But I'm not sure how you would answer that question.
Yeah, the 95% of proof of concepts failing or not being continued and deployed is an interesting number and a shocking number. Now, if I take Siemens as an example, and I was in the comfortable position, challenging position to run an AI strategy exercise one day where I looked at more than 400 use case ideas. First of all, if you take all the use case ideas that we collected, the majority of them would be in the commodity space. Now, if in the commodity space, the productivity gains are marginal, then you have many of them, yeah, 80, whatever, and the return on invest is very limited. And at a certain point in time, management says, okay, it's great that you had your learning curve, but we are not going to put this in production because of the missing return on invest. So let's stop it. Yeah, that's one aspect of the problem. The second a key failure factor, so to say, yeah, the opposite of a key success factor, is the following situation. When we do a proof of concept, we basically look at two things. In industry, we receive data sets, either from the shop floor or out of engineering. I wouldn't say on a USB stick, but you get a record set, yeah, handed over to a data scientist who then uses their laptops and a Jupyter notebook to develop a model. And the proof of concept is a lot around the quality attributes of the model itself. So, we look at accuracy, F1 scores, and so on, and then we find out, okay, the model performs well in 92% of the cases, and the number of false positives and negatives is manageable. So we regard this as a good proof of concept, and then we move on. Yeah, in many cases. However, for industrial AI, you need to put so much emphasis on what we now call the harness. Yeah, after the code leak of Anthropic, there has been the term defined, coined, the harness, and everyone was pretty surprised that 89.5% of the lines of code of Anthropic were not about the model, but it was around the harness that is surrounding the model, because an AI model is always, specifically in industry, but also with LLM providers, part of a larger system. And in industry, that larger system has to be designed diligently, and it takes a lot of effort to make sure that from a systemic perspective, not just from a model performance perspective, but that the overall system works. And the scope of proof of concept work in the AI space is always limited to the AI model. But you have to, and let me give you a couple of examples. A machine tool builder is collecting time series data to maybe do an anomaly detection for predictive maintenance, right?
Yeah.
And maybe for that purpose, they are using an AI accelerator, or they plan to have an AI chip, a GPU, whatever, built into their machine because of that, time series analysis. And now that a machine tool builder is selling internationally, so they are selling machines to China, they are selling machines to the US, they are selling machines to Europe. And US AI hardware technology cannot easily be exported to China. So as a matter of fact, they have to use a different AI accelerator in the machines that are selling to China, like a Huawei chip, for example. But the floating point calculations in the last digits between an AI chip from Huawei and an AI chip from NVIDIA differs. So the model will actually give different results, whether it's run on that hardware or run on that hardware. The proof of concept never covers these challenges. These are exactly the types of challenges that you discover and have to address between a successful proof of concept and the deployment. And because you have many of these challenges, this is just one example, but you have several of them, the differences between the cost of the proof of concept and the cost of a successful deployment are a factor of 5 to 10. So you spend $200,000 on the proof of concept, data scientists, laptop, Jupyter notebook, and so on, a little bit of SageMaker, whatever you take, $200,000. Painful data acquisition, but finally you get that USB stick, right? But you spend $1 million at least. That's only the factor of 5, not of 10. $1 million before you can deploy that solution truly into your machines, into the field. $1 million. Now, if you have an AI use case that has a return of, say, 100,000 euros per year or 200,000 euros per year, at the proof of concept time, that looked nice. You said, okay, I'm spending 200,000 for the proof of concept, and maybe we will end up having a break even in 2 to 3 years. But not if you do the full diligence and if you are honest about the cost that you have to expect, because then you end up having at least $1 million cost with 100,000 savings per year. And then you go to knock on the door of your CFO and say, we may have a break even in 10 years from now. And then the CFO cancels the whole thing.
Yeah, definitely.
So it's really a very important failure, structural failure that happens many, many times, that we are over enthusiastically hopping into the proof of concepts, not being honest about the costs that we expect before we can move stuff into production. Just take this rule of thumb. It's a factor of 5 to 10, compared to the proof of concept costs. And then redo your business case. Just do that forecast and that estimation.
Yeah.
And 90% of the activities will fail. And if you do this honestly, you even will not start into the proof of concept. So, that's one of the reasons why 95% of the proof of concepts then don't move on later on, because they were started ignoring the cost factor, true cost factors.
Understood. I have one question. You call it in the book pilot purgatory, I believe, where basically use cases are not being further developed or maybe canceled or whatever. We then get the clean data set, the USB stick, how you call it, later in production systems. I'm wondering, especially Siemens, I mean, you're collecting so much information, so much knowledge, so much context over time. Isn't that a competitive advantage to then later on say, we can much more quickly say, hey, use case number 359, we already know what failed in the past. We can make a much more intelligent calculation right now, a cost estimate, and what the return on invest will be. So failing faster and faster so that the organization itself will become more intelligent over time for specific AI use cases. Or do you say we almost always start from scratch?
So a couple of answers on that one. First of all, the fact that we are selling a lot of automation technology into the markets of system integrators and machine tool builders does not translate into we have any access to the data that is actually running on the PLC. Okay? This data is either system integrator or OEM, machine tool builder data, or end customer data, according also to the EU Data Act. Siemens is out of that equation, which makes it difficult for us, by the way, to truly work on use case specific solutions, say for the metal industry or for machining and so on and so forth, because it is clear that we don't have access to the data that our customers are running via their machines. Okay. On the other side, Siemens is a manufacturer by ourselves. We are, having mechanical production. We have a lot of electronics production because in our core, Siemens Digital Industries, building IPCs, building PLCs, building all sorts of electronic stuff, also for building technology. In our core, we are, 60% of what we manufacture is electronics. And of course, we collect data for electronics manufacturing from the processes, from our own production lines, from our own drives, from our own conveyor belts, from our own, pieces of robot technology that we build. And we are systematically now collecting the data also to help building products that we can sell to our customers. One example is we have access to a lot of printed circuit board designs because that's what our products are made of, majority. And we are also selling software that our customers use to design PCBs. And of course, we would like to use our own PCBs to train an AI that then helps our customers to design their PCBs faster. And so we are collecting internally time series data from drives. We are collecting data also from buildings because we have building technology and we are operating buildings, Siemens buildings, for example. We are collecting data from the electronics design space and from the electronics production to then build data pools internally that help us developing those pieces of AI that then make it in our portfolio and ultimately help our customers to perform their duties better.
Mm-hmm. I'm wondering, you mentioned in your book a 67% higher chance of a use case being successful when it's externally sourced, when it's an externally sourced system. That brings up the question, or that begs the question, build versus buy. I even had that back then when I was working for the startups in London and also in Munich in the simulation space / AI space. Do we build it now? We always have to have an objection from the customer. Well, do we now buy the solution off the shelf because you guys are the experts, or do we build it in-house? What's the better solution here?
So for me, the strategy is very clear. The AI talent as the most important resource that we need to build AI solutions. The AI talent is scarce. Yeah, it's probably the bottleneck. The combination of AI talent and engineering domain expertise is even more scarce. So you don't find these people easily. You don't hire these people easily, specifically because we have another hype, which is called physical AI and world models, that Silicon Valley is now investing billions and billions in world models that should be, in the end of the day, helping to run the physical world. So they are hiring anyone they can get in that space. So talent is really, there's a war for talent. So we need to be selective. And coming back to my example, and my 3 pillars or my foundational layers of commodity use cases for a learning curve of all the employment base, and then the strategic and differentiating use cases, I would absolutely recommend to use your talent that you have or that you have access to only in the space of differentiating use cases, because that's where they can make a huge difference. We have several players in the Deutsche Mittelstand who, by the way, invested in AI startups strategically, like, a 10% ownership, 10% of the shares of that startup and so on, to make sure that they have access to the talent. And then let's not use that talent to create agents that help you sorting your Outlook emails. Yeah, you need to work on differentiating use cases. And one example of a cluster of differentiating use cases is design space exploration, where I have great examples in my book. Siemens Energy reworking gas turbine design, or Tesla finding the best materials, material discovery that worked with the gigapress. And you are into CFD, you can easily appreciate what it really takes to develop, find and identify a metal alloy, an aluminum alloy that is well suited to fit to the requirements of the large gigapress in terms of being liquid enough to be to be injected into the last corners of this incredibly huge mold, and then cool down fast enough, because the faster that metal alloy cools down, the higher is your throughput of the gigapress. And then you have to meet requirements of the car itself, like, is it stable enough with that aluminum alloy? And is it robust enough against road chemicals, right? So you have a multi-goal optimization that includes CFD and thermal simulation and all of that stuff. And if you iterate through 10,000 variants of materials and you simulate how they behave, then obviously you need to be able to use AI to accelerate that process, and find the right material, because that ultimately is still a very high differentiating point for Tesla. The margin per car of Tesla is still unmatched by most of the Western car manufacturers. Yeah, and the gigapress is one of the reasons why that is the case.
You mentioned now a very important point, the multi-goal optimization. I'm wondering, like, industrial AI is much harder than, let's say, classical AI. For example, building a large language model to sort Outlook emails or to formulate Outlook emails, right? Are there any other reasons why industrial AI is so hard? And by the way, there's also not an undo button. I cannot just say, hey, you know what? I'm building my orchestration platform, or I'm using the orchestration platform N8N, to then later on say, well, my machine now runs a workflow which I can undo. There is no undo button or like Control Z button. That makes it fundamentally harder to actually implement AI in the industry. Is there any other reasons why it's so difficult to implement AI in production systems in the industry?
Well, one of the reasons is certainly that in many cases you need to get access to the data, and there are many specific data challenges. Just to give you one example, if I look at a PLC and a PLC pace, right? It has a cycle time of, say, a couple of milliseconds, 5 milliseconds. Mm-hmm. And then the PLC runs into an error state. And that error state is gone in the next cycle. It's only there for 5 milliseconds, and then it disappears. And then you have a data access layer, call it OPC-UA server, or an MES system that pulls from the PLC, but it does this only every second or every 5 seconds. It will not be aware of the error state within that particular cycle of the PLC if the PLC hasn't been developed and programmed to have a queue that is actually buffering the error state, so the MES or the data access layer can actually read it out later on. Now, maybe the system integrator that you have tasked to develop your production line 15 years ago or 10 years ago, they didn't have their mind around buffering error states. They just did it in the way the PLC needs to do it, right? And now you come today with an AI use case and you want to leverage everything you can, but you are not redeveloping, you are not refactoring the PLC code that someone has written 15 years ago of a stable system. Your production line head or production head says, you guys are crazy, don't never touch a running system. Yeah. So this is a specific example of a data problem in industry that makes it hard. And then the second thing that I'd like to articulate is physical AI doesn't mean only it is AI that runs on a physical machine. It also means it is an AI use case that is related to an investment asset that is physical, that is depreciated over at least 7 years if you look at a machine. And if you have requirements in terms of the machine, in terms of the data points that it provides and so on, it's very difficult to convince your CFO to replace that machine simply because it does not deliver that data point. And the CFO will say, well, but the depreciation cycle of that machine is not over yet. We keep it another 3 years. And then the data scientist goes into suspension mode for 3 years, and you have to wait until that change has been made, or you find a retrofit way or a soft sensor that provides you with this additional data point that you are longing for. So being in the physical space implies a lot of stuff. And then last but not least, we are in an industry that is specifically in the shop floor space very fragmented in a sense that you have companies providing components to machine tool builders. You have machine tool builders that are developing and producing machines. You have system integrators that are integrating those machines into a production line. And sometimes you even have a system integrator that builds the line, but another party that is actually operating and monitoring the line on behalf of the customer sometimes. Sometimes the customer do it by themselves. Sometimes they have a provider to operate a production line. And whenever you want to do a change that is needed for a holistic AI use case implementation, throughout your technology stack, your production technology stack, you have to align with all these parties. You have to put change requests on the table. You have to negotiate prices for the changes that have to be implemented and so on. So the fragmentation of the supply chain in industry for production is certainly not doing a good job in accelerating AI implementation in industry. While if you look at the digital players, then it's not only that they have the comfort of working in a digital space and the collection of another data point, a new data point, for them is typically a very small change. It is also that the supply chain of Google, for example, or Facebook, for example, or Amazon of this example, for example, the supply chain is a lot less fragmented than the supply chain in industry. Does this make sense?
Makes sense. I'm wondering, as a follow-up question, you talked about the CFO quite a lot. There's 2 different tiers. So you have to invest in tier 1 first, which is data platform, governance, and infrastructure. So you first have to make them aware that there's a stage before the actual use case that we are going to pick. How do you convince them to do that? Like, do you make a rough back of the envelope calculation and say, well, here you go, guys, believe us or not? Or how does that work in the industry?
This is, you are right. You can look at needed investment into tiers. And my suggestion also in the book is to make a very clear distinction between foundational investments that you need to do to establish a capability for your company, and then use case specific investments where you look at a return on invest opportunity on one particular use case. And why am I suggesting that split? Because we have so many activities that are so cumbersome. And I talked about some of the data access challenges right now. Yeah. That if you code these activities from an effort perspective into one single use case, you will almost every time fail to have a positive return on invest that would allow to implement the use case. And this is why, to give you a couple of examples, Johnson & Johnson in America decided we have one gigantic project to make our production ready for OPC UA. So every device, every machine will be transformed to be OPC UA compatible, the semantics of the interface, the standards of data extraction, and so on. And they decoupled this initiative from one particular use case that you then can implement, whether it's predictive maintenance or process parameter calibration or whatever it is that you then do on a subset of all machines. And they book the effort for the OPC migration, OPC UA introduction, rollout, transformation, and so on, onto one cost center, and look at it as the creation of a strategic capability. If you want to convince your CFO to do that and spend that money on developing a capability, You can do this with the help of strategy consultants that basically report how transformative certain AI activities are, particularly done by your competitors. Because that's the role of strategy consultants, that they have insights into what is done by what player in a certain industry, and then the fear of truly losing competitiveness against your competitors will typically allow a constructive discussion with your CFO, what portions of cost should really be allocated to the development of a strategic capability, and what remains left then to be an individual use case-based return on investment calculation. And that's a strategy, a way forward that I recommend to every company.
Interesting. I like that. Obviously, people are also involved in the whole AI strategy. And one thing you talk about in the book, which I really like, is the competence penalty, which is funny because actually, when people use AI, we think they're actually smarter using AI, but they're perceived by their colleagues less competent and actually lazier when using AI. If I'm getting that correctly,
Yes,
like
that's one aspect,
yeah,
and it's actually matched by what they call slop, right? And maybe you have
yeah,
seen the phenomenon by yourself,
mhm,
that you are asking a colleague to help you with something and prepare a document or prepare a concept, and then you get something you know written with the help of generative AI and large language models, and it looks comprehensive on the first glance, and then you read into details and then you find out it's too much average building, it's too generic, it doesn't really hit the point, it doesn't really hit the specifics of your company environment, and so on and so forth. So because of this quick and dirty, it took me 15 minutes and now I have a comprehensive document, but I even didn't spend enough time to read it properly and take out the the parts of it that are too generic. This this phenomenon is a true phenomenon. And then there's another cultural phenomenon that I'd like to stress, which is engineers hate fragility. A good engineer is someone who tries to reach a given goal with the least introduction of uncertainty that he or she can target. Yeah. So the simplest way, the most robust way, the minimum change that is required to achieve a piece of new functionality, for example, or fixing a bug. Why? Because they hate uncertainty, and the more they do, the more uncertainty they introduce. And AI, by definition, yeah, in most parts, at least on the probabilistic side of AI, is clearly the introduction of fragility and uncertainty into the engineering world. And you need to work a lot to rebrand AI to become a helping tool, for example, for design space exploration of design spaces that are so huge that a human cannot work through that design space by themselves, right? And then it becomes a tool for an engineer who actually go through 10,000 variants of how you would solve the problem and assess them and rank them by simulation, and then present me the top 10 variants. And this is what I will look into then as a human to select the variant that meets my goal best, including the least introduction of risk and uncertainty. So these types of phenomenons, cultural phenomenons across the employment base, like the competence penalty or the engineering specific, the specific ways of how engineers think and feel, all of that needs to be addressed if you introduce AI into the industry and engineering world.
yeah. I would like to talk to you about, Boris, the most promising and least promising use cases, especially for industrial AI. Can you name a couple of those? Maybe as some sort of guidance, because at the end of the book, you write, we must start now. So maybe like if, for example, a mid-sized manufacturer like watches this podcast right now, there should be like practical advice that they can maybe start next Monday with their boss if they want to start introducing AI. So maybe some practical tips from your side, Boris.
Yeah, if you go through that book, of course, you will see all the enterprise functions of an industrial company and the solution briefs. And the solution briefs means there are commercial offerings out there. You can pick up the phone. And to give you an example that I like a lot, I hate time sheeting. So if you are in a business or part of your business where you need to write timesheets because you need to allocate your hours and your time to different projects, then AI-based timesheeting that calls through your Outlook calendar and pre-populates the timesheet because it can pretty well understand what meeting was related to what project, for example, right? That is a low-hanging fruit. You know, your employees will love it. There are commercial offerings out there, 2 or 3 or 4, and I have a solution brief of one of them in the book. So that's a low-hanging fruit. And this comes back to buy versus make. You know, these commodity use cases in many of the enterprise functions is something that you can actually acquire. It has product level, it's out there, it works, it's proven. Go get it. Yeah, great starting point. But when it really comes to identifying those differentiating use cases, say, you know, product design, improving product design by design space exploration, or also offering services on top of your products. So you move towards availability-based offerings, towards outcome-based services, maybe, yeah. AI can play a major role, you know, IoT data, doing data analytics to manage the risks better than a customer can manage those risks by themselves. The risk for machine failure, the risks for a wrong process parameter calibration that maybe takes in raw material, but then doesn't provide the output quality that you need because the process parameters are wrongly set. This is something that you need to discover, everyone needs to discover according to your business, your sub-industry that you are working in, and your positioning, and then use the brain power that you have on your payroll or great partnerships with startups, with Fraunhofer Institutes and so on. And this is where the intellectual brain power and the development effort then should go.
That makes sense. Boris, before we wrap up the podcast, I have a little game for you.
Go ahead.
Which is a rapid fire to close the podcast. We have a couple of rounds, let's say 4 rounds in total. Round number 1 is you have to say if the technology or the sentence I'm saying or the word I'm saying is overhyped or underhyped. So we're going to start with humanoid robots in the factory. Overhyped or underhyped?
Absolutely overhyped. It's a hoax.
Okay, good. At least we agree on that one. That's good. Agentic AI.
There's a tendency to underappreciate its power. However, a lot of quality management challenges are still ahead of us to manage qualities in those distributed systems, because as a matter of fact, they are distributed systems.
Mm-hmm. Number 3, digital twins. Overhyped or underrated?
Underrated. We need to have a lot more of them. And I also underrated in that context yet is the industrial metaverse, which is super interesting as an aggregation layer of many component digital twins to become systemic digital twins. There's a lot of potential in that stuff.
Very nice. The machine economy.
Oh, the machine economy is something very fascinating in a sense. I would say today it's overhyped. In a decade, let's talk again in a decade.
Okay, we have another episode then in a decade.
Yes.
I promise. Last one for round 1. AGI is a topic for industrial companies.
No.
Okay. Basically overhyped.
Basically overhyped.
Okay, then now round number 2, this or that. You have to pick one. Open source or commercial LLM for industry?
Open source.
Nice. Make or buy?
Make for everything that is strategic, buy for everything else.
Nice. A broad data platform first or first visible use case first?
Broad data platform and good data strategy first.
Very good, yeah. Vibe coding, blessing or security risk?
Security risk.
Okay, we agree on most of the things. Round number 3, to the point. The biggest misconception about industrial AI in one sentence or one word.
That it scales like social media AI.
The one use case every industrial company should implement in 2026 or 2027.
Design space exploration.
The most underrated role on an AI team.
The quality manager.
Okay. One AI buzzword you would happily bury.
If we span into robotics, is certainly the humanoid topic.
Okay. And last one for round number 3, the mistake you see again and again in pilot projects.
Ignoring the heuristics of how more expensive it is to take a proof of concept into a deployed solution, like that factor times 5 to times 10, that is accepted by the experts, known by the experts, and never be incorporated into the decision making.
I like that. That's good. Last round before we wrap it up, Boris, some personal questions. A tool or model you use yourself right now and would recommend to everybody listening to this podcast?
I used Gemini happily and a lot, particularly deep research from Gemini, to prepare some of the book chapters. And that helped me to overcome the fear of the empty page, as you would say. And then there still have been 5 iterations and spicing it up with solution examples and case studies from out of the network that I had. But it was very helpful for me.
Who should read this book first, the CEO or the plant manager?
I think the plant manager is a great starting point for a company reading that book. The CEO, it's good for a CEO as well. It's particularly useful for a plant manager.
Your book in 3 words.
Inspiration, what's possible, and to-dos and hygiene factors to run AI initiatives in industry successfully.
I like that. That's good. Optimist or realist when it comes to AI in industry?
Optimist.
Who are you? Nice. That's good. And last one, Boris, and we're done. The one prediction for 2030, if you can make one, you would happily be quoted on.
The one prediction I can, well, AI, agentic AI in engineering is a common theme and actually helps mankind to significantly reduce the environmental impact of the next generation of products.
Love it. I have one last question because we talked about agentic AI and then we really wrap it up, Boris, promise, is about the topic of pseudo productivity. How can we overcome that engineers just stupidly prompt any systems or use agentic AI for random things and we make them more focused? Because I think the new oil is attention, especially for engineers. So how can we teach engineers to use AI tools more intelligently? What's your take on this?
Build the AI tools into the pipelines and engineering workflows. I mean, just, you have a background in CFD and CAD and so on. Just think of meshing, right? So it is not a question of an individual engineer prompting something. It is a question of establishing a set of agents that is supporting the overall design and engineering workflow. And then there is no choice for an engineer to kind of stay within that pipeline and engineering workflow. And by that, he or she uses the powers of AI implicitly.
I love that. Boris Scharinger, it's been a pleasure. Thank you very much for being on the podcast. And I'm sure we'll have a second part or maybe third part in the future. But thank you very much for this.
I would love to.
Podcast.
It has been a pleasure. Thanks so much.
Thank you.